Hello everyone. Today we are going to solve top interview 150 question. So question number one, which is related to an array, that is merge sorted array. So problem states that you are given two integer arrays, nums1 and nums2, sorted in non-decreasing order. Okay, and two integers m and n representing the number of elements in nums1 and nums2 respectively. So what we need to do, we need to merge nums1 and nums2 into single array sorted in non-decreasing order. So merged array should also be sorted, and that should be non-decreasing order. Okay, and also it is given in the problem that you need to return nums1. Not actually, you don't need to return nums1. You just need to do merge and sort in place. So that should be there in nums1. You don't need to return anything. It will automatically read nums1. So sorting should be done in nums1. So how we'll approach this problem? So let's see. Okay, so let's open this here, right? So you are given two arrays, nums1 and the number of elements in nums1 is 3, and you have nums2 and number of elements in nums2 is also 3, and you need to sort merge and sort these array, and the output should be something like 1 2 2 3 5 6. Okay, so one way can be like we can concat these two arrays, uh, like here you have 1 2 3, right? Size of m is 3, then you can start with the m plus 1. Okay, and then you loop through nums2 and add all elements from num2 to num1, and then uh, like you'll get the merged on nums1 and then sort nums1, and that will be the answer. Okay, so following this approach, time complexity will be n log n, and this is not optimal. So there is O of n solution for this problem. So what we'll do, actually we need to merge nums1 and nums2, and there are some empty places where we can place num2 element. So our approach will be in nums1, then there are yeah, m equal to 3 numbers, and in nums2 there are n equal to 3 numbers. So we will compare from end of both the arrays. So for example here 6 is compared to 3 and 6 is greater than 3, then uh, here at the last index 6 will be placed, and then you will decrease the counter. So here because 6 is already replaced, so 6 is already placed at its appropriate position, then counter will be decreased by 1. So now the second counter, suppose it is j, it will point to 5. Now 5 will be compared to 3, and 5 is again this is greater than 3, then 5 will be placed here. So here it will be now 6. Okay, and 5 is greater than, it will be 5, right? So now again second counter will be decreased by 1. So suppose it is pointing to maybe j, so now j will be pointing to 2, and suppose this is I, so I is pointing to 3. So 3 and 2 will be compared. Of course 3 is greater than 2, so like I will be decreased by 1. So I will be pointing to 2 now, right? So it will be pointing to 2, right? And 3 will be placed here, right? So now I is pointing to 2 and j is also pointing to 2. So we can maybe I decrement the I by 1. Okay, so here now I will be decrementing by 1. Okay, so I is 1 here, decremented to 1, and now we have to place something at this location 3. So 2 will be placed here at this location, right? Now I is pointing to 1 and j is pointing to 2. So 2 is greater than 2 is greater than 3. Sorry, 2 is greater than 1. So 2 will be replaced. 2 will be placed here, right? And now j is pointing to -1, right? So now there is nothing to merge here in nums 1. So we can conclude the solution. So this will be the optimal solution, and the time complexity will be O of n. So let's code this problem. So here let I have I is uh, I is pointing to m, right? So for index it will be m minus 1, and j is n minus 1, and to place the elements I have k, that is m plus n minus 1. Okay, so while okay, just a minute. So while I need to check I and j should be greater than equal to 0, right? So I is greater than equal to 0, and j so in that case what will happen? Suppose nums1 I is greater than or equal to nums2 j. In that case what we'll do, we will place nums1 I at kth position, right? So in this case nums 1 k equal to what will it will be equal to nums 1 I, and also will decrement I, and also will decrement to k, right? And in else case, so nums 1 k minus 1 k. Okay, so right now once this loop will break, either I will be less than 0, okay, or j will be less than 0. So if I is less than 0, then we'll already have a solution. But if j is not less than 0, then in that case we need to merge elements from second array to first array. So we'll check while until it is not -1, we will just place elements of nums2 to nums1, and that's it actually. Yeah, that will be all for our final solution. Let's run it. Let's submit. Yeah, so it gets submitted successfully, and the solution got accepted. And time complexity of this algorithm will be O of n, and O of, maybe you can say O of max of m comma n. So whatever value will be more from m and n, so that will be the time complexity. Okay, so time complexity will be O of max m comma n. That's it. Thank you. Thanks for watching the video. Please consider to subscribe and like if you like this video. That will encourage me to create more videos. Thank you. Thanks a lot.